But the big question is, why does this function have an asymptote? Why does this function have a hole? That's the question. Because they have the same non-permissible value. Why is this guy's non-permissible value manifest itself as an asymptote, and why does this guy pop up as just a hole? And why does this look like a line, and this look like a regular rational function? Why do their 2 points of non-permissibleness look completely different?
Oh, yeah.
Right? This one is an asymptote. This is a hole. Why?
I don't understand.
What's going on? See, isn't it cool?
Yes.
I can't find the point. I feel like I'm
Okay, so I'll tell you why. This is the difference between a vertical asymptote, and the hole is called the point of discontinuity. Okay, so this is on the next page of your notes here.
Can you say
So
that again?
yeah, I'll put it up here.
Like the point of this
Continuity.
continuity.
Yeah. So f of x has
What is this witchcraft?
point has a point of discontinuity. That's where it's no longer continuous because there's a break in the graph. It's no longer one continuous smooth line. And this guy has an asymptote. Okay? And the question is, why are they different? Why does that plus and that minus make that big difference? Here's why. If you take f of x, just focus on f of x for a second. Can you factor the top or the bottom? Guys?
Mm-hmm.
Can you factor the top or the bottom on f of x?
You can factor both.
You can factor something out of the top and the bottom. What can you factor out of the top?
X.
X, okay. And you get
X
minus 2. What about the bottom?
You can factor 2.
You can factor 2. I'm going to factor negative 2 though. Okay, because I want it to match what's at the top there. Right? Negative 2 factors out because if you went negative 2 times x, you get negative 2x. If you go negative 2 times negative 2, that's positive 4. Okay, so you're just factoring negative 2 instead of positive 2 so that you have a common factor. And then, what? Can you cancel those? Are they common? Yeah, they reduce each other, right? These cancel each other. And you get x over negative 2, or just the line negative 1/2 x. See that?
So then why is there why is there that 1 point?
So that's a good question. There's two things happening here. Number one, your calculator is doing all of this before you graph it, right? If you put into your calculator, if you put in something like f of x equals x times x, what are you actually putting in?
X squared.
Like you're putting in x squared, right? Your calculator knows that there's some calculations that need to be done to that expression to make it accurate or simpler, right? Or if I put in f of x equals 10 minus 3, what would it actually graph? 7. Y equals 7, a horizontal line at 7. Right? So your calculator is doing any necessary calculations or simplifications and then graphing it. Okay? That's why this function comes out as a line, because there is a factor that cancels. Why the point of discontinuity? The answer is because originally there was a non-permissible value in the denominator. Even though it gets canceled out, originally, from your original function, there is a non-permissible value. Right? So you see why? So, if you look at g of x though, let's just take a look at g of x, see if we can reduce anything. Okay, so we can factor out negative 2 on the bottom again. Whoops, getting ahead of myself. Factor x up top, we get x plus 2 left over now. And negative 2 on the bottom. Can I cancel anything?
No.
No, right? These are different. There's a plus and a minus, so they don't cancel. So that function doesn't change at all. You understand? So the point is, you get a point of discontinuity, and this is very important. Okay, you get a point of discontinuity when there's some kind of factor up top and down below that cancel, and it changes the whole appearance of the equation, but it leaves holes in your graph where those original non-permissible values were. Does that make sense? That's when the point of discontinuity happens, is when there's factors that cancel with stuff in the denominator. Asymptotes, nothing cancels. It's just based on non-permissible values. Okay? Also, I'll write something down here for you guys to write. Does that make sense? You understand the difference between those two weird things? You guys get it? Yeah? Okay. Yeah, the key is, can you factor and then cancel something in the bottom? And if you can, you'll have a hole. If you can't, then you'll just have asymptotes. Sometimes you could have both. But any factors that are canceled become holes. Got that? You say it enough times. So here's another example. Just really quick. F of x equals x squared minus 5x plus 6 over x minus 3. Okay, asymptote, or maybe I shouldn't say asymptote. What's the non-permissible value here? 3, right? The question is this an asymptote, or is it a point of discontinuity? Is it a hole, or is it an asymptote? And the way to know that is to factor what you can. So we're going to factor this up top and see if anything cancels with x minus 3. If it does, it's a hole. If it doesn't, it's an asymptote. Okay, so let's just check that out. So this 2 factors of 6, that adds equal negative 5, x minus 3, x minus 2. So it does look like we have a factor that cancels right here. Right? So this is actually the line x minus 2, so a slope of 1, y-intercept of negative 2. But there's a hole at 3. Make sense? So this would be a point of discontinuity. Weird, hey?